Alrighty then. Does anyone want to read this aloud? Raise your hand. I used to do this. I used to make kids read this. Cooper, you moved your hand? No? No one wants to read this aloud? They would know where Cartesian coordinate system comes from? The word Cartesian? Renee? Anyone know Renee? Renee Day? Anyone? Renee Descartes? Cart, which is spelled Cartes. So Rene Descartes came up with according to the name here, the Cartesian coordinate plane, which is just the XY axis. Right? You okay? You're making a face now. You're the one that got it right.
Well, it was just like easy.
Okay. All right. All right. So is not the only way to locate a point. Fine, I'll read it, Cooper. All right. In the polar coordinate system, points are located by using directed distance and an angle. All right. You're going to practice this here as we go. The Cartesian system origin is called the pole. So right now we're going to write that right below this. Pole is the origin. Now I got a really easy way to derive how to toggle back and forth between these two things. And actually we got some weirdly cryptic notes here that we're going to go through. But here it is. Here's your Cartesian coordinate plane. There's your, There's your polar coordinate plane. But what you're going to have to imagine is both the polar coordinate plane and the Cartesian rectangular coordinate plane slapped on top of each other. And then how do I get points in the same position through two different ways of writing them? Okay, now we do have a lot of exercises that actually do that, so we should be good to go. Look at this too. They have the over 12s. That's neat. All right, so they actually add the over 12s as an added fun thing as opposed to just our 3s, 4s, and 6s. So good coordinate plane there. All right, so I'll show you how you graph. It's very easy. There's our polar coordinate plane. I had to check my words there to make sure I didn't say rectangular. Rectangular is Cartesian. Rectangular is XY axis. So I'm going to say rectangular a lot as well. So 2 just means you're 2 away from the origin somewhere. 2 comma pi over 6, well, that's easy. Here's 2 comma pi over 6. That's how you graph it. Pick colors if you want so that you can have these look different in each case. Right, and then we got some really weird directions. I want to rename this coordinate, but I want an R value that's positive. Well, I already have that. So I already have 2 comma. So that's going to be another way of writing this coordinate. R being positive. It already is. So there you go. And then, oh no. I want the angle measure named negatively. Everyone in this room should know how to do that. How did I get 2 comma pi over 6? Because here is the pole, or the, that's called the polar axis. And then I just went pi over 6 this way. I just want to know, how do I name it this way? And everyone in this room should know how to do that. 3, 2, 1, go. Only Doa. Negative 11 pi over 6. Everyone else is sitting there. Some people are just chomping on their gum and won't answer a question. I see you out there. Then they put their head down. Don't look at me. Got your earbuds out? Turn your head. Good. Next. What's this next? Oh, no. And then I'm going to prove this later. That says a radius that's negative. This is going to be wild. So that means I got to say negative 2 comma. And I'm going to just tell you this is what happens. And then hopefully I'll remember. It came up later, and I said, here's proof. We had to convert from polar to rectangular, vice versa. And then it proved what ended up happening. It was polar to rectangular. All right, what happens with a negative is and I got to erase this because this is going to get messy if I don't. And this, I don't want that there. So what happens with negative 2 is this. So if I put negative 2 here, what it does is actually reflects it over the pole 180 degrees to the other side. So right now, how do I get here? I got to graph negative 2 over here and then flip it to here. So that means that's this angle measure right there. And it just is. You have to accept it. And then later, I'm going to convert one of these, and then you're going to see how the rectangular coordinate is actually in the opposite quadrant compared to the angle measure that's given. You will see. You will see that it actually happens. So a negative radius means 180 rotation. You got to go exactly across the pole to the other side. So that's why this still lands at that red point. Because here's 7 pi over 6. Here's 2 away. But negative 2 flips it over to there. I'm landed right in that same spot. Then this last one is really weird. But it's just kind of proving the point that how many ways can I draw this? How many ways can I write this coordinate? Starts with an I. I-N. An infinite. We can do this all day long. Now let's go back to a positive radius. Okay, fine. And then let's do, what does this mean for an angle measure? That just means I do more than one rotation. 2 pi to 4 pi means I do one rotation, then I do it again. So where am I at? I'm at pi over 6. What's another rotation after pi over 6 to land in the other one, land in the same spot? Add 12 pi over 6. And then you get 13 pi over 6. So we could do this forever. We could do this negative 2, and then we could add 2 pi or subtract 2 pi from 7 pi over 6, and do this forever and ever and ever. Next one. This is why some of these I don't have to do. Negative 4 comma 2 pi over 3. That is letter B. That is what they ask you to do in letter B, so I don't have to do that one, right? Negative radius with an angle measure between 0 and 2 pi. But how do I graph it? I go to 2 pi over 3. I go 4 out, but wrong. I go a 180 reflection to that point. That's where that point is located. Okay? Now, I wish they could just give me what would be easy. It would be 4 comma 5 pi over 3, but that's not the options. I want a positive radius. Look at the directions up there. But a negative angle measure. What's that angle measure right there from there to there? Negative pi over 3. No, you guys, I'm going to start getting out the calculator as well. You're as bad as the ABers. Every time I ask for group responses, nothing. Right, Doa? Didn't that just happen the first time? You were the only one, even though you showed up almost late. Don't say anything. Okay, now R 4 comma. Okay, so what is this angle measure? This is 5 pi over 3. Right, so I guess I do have to do a little bit of thought process off of 5 pi over 3. But 5 pi over 3 is between 0 and 2 pi. So 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. This is just to satisfy these silly little directions there. You're okay. Yawns are allowed, but just I feel offended that I'm boring someone. Alrighty. Do we have a positive and a negative? Yeah, we do. So guess what? Bless you! Good Lord. Jeez Louise. All right. Is that the first one? A positive radius and a negative angle, so I don't have to do that one. That's nice. And then the next one is a negative radius. Oh, wait, what am I doing? Oh, my goodness. So 5 comma, let me get rid of my stuff here. I feel like I teach different when I'm recording. It's actually better I show. Oh, no! 1, 2, 3, 4. Okay, well, I'm off that grid a little bit. They didn't give me enough circles, right? There's not enough circles for a radius of 5. You just have to go outside. That happens a lot on a rectangular coordinate plane. We have to go off the plane a little bit. With what's provided, it's still there, but all right. And then how do I get that with an angle measure? Wrong. Oh yeah, no, I'm looking at this one. Negative radius, but an angle between 0 and 2 pi. Oh, there we go. We know what it is. 7 pi over 4. It's right there. That's easy. And then right? Okay, so yep, an angle measure between 0 and 2 pi. And then the last one is a positive radius, but then an angle measure that's between 2 pi and 4 pi. That just means I have to add another one. So 8 pi over 4 plus 7 pi over 4 is 15 pi over 4. I don't remember writing that yet last hour. Let me see if I did do that one right. Did I? Yeah, okay. I don't know why I didn't remember that. Okay. All right, back. Just my memory. Okay, then the last one, -3 comma negative. So here's what -3 comma negative is. I'm trying to choose a color. So I did purple, green, red, blue. There we go. All right, here's -pi/2 directly down here. All right, so I go 3, 1, 2, 3. Wrong! I gotta flip to the other side of the pole to get up there for -3 comma pi/2. Notice even though it's r comma theta, I go to theta first, then I do r, right? And that's going to be needed for, especially with a radii that's negative. Okay, so again, a rectangular coordinate plane, it's going to be, yeah, pretty cool. All right, and what are the rules? Positive radius, but a negative angle measure. Okay, here's the problem with this. For a negative angle measure, I have to go this way. So that's -3 pi/2. That lands in that same spot. Okay, so landing in that spot, I'd have to go that way, right? Giving you explanations here. All right, and then the next one. Do I have any of these that are no? I think I have to fill out all of these. So it's a negative radius, but then a positive angle measure. So this is wild. So what I need is a negative radius, but a positive angle measure. So that means I have to go like this. This would be 3 pi/2. Because here's what, oh, here's why. Like I just said, I'd go to 3 pi/2, which is right here. Go 1, 2, 3. Wrong. I got to go across the pole to up here. All right. But that's not too bad. We know 3 pi/2 is the same angle measure as -pi/2. So it ain't no thing. Anyone? Chicken wings might be on my dinner tonight. Oh no, it's Friday. This is a public school. Don't you dare. Don't you say a word. Okay? And then the last thing, 3 pi/2 plus 4 pi/2 is 7 pi/2. 7 pi/2. I ate fish for lunch. Delicious. I eat fish because you got to try. You know, seriously. Don't let your parents tell you that you can't. Anyway. Ready? Who was in Compass yesterday? Anyone? Remember? Yeah. Yeah. Okay. I'm gonna leave this coordinate plane as is and just go by ones. But you know, it's kind of like a small coordinate plane. I don't really need this many. You know, like I think it's 10 across, 10 high, 10 low, 10 by 10. Okay, so rectangular coordinate is 1 comma 0. Let's go ahead and write that. What is that as a polar point? Okay, well, we just got to have a little imagination. All right, how far is it from the pole? How far is it from the pole? 1. So it's 1 comma. And then what is that angle measure right here? What is that angle measure that's right on the, you know, on the unit circle? What is that? 0. Or what else? What else could we put? 2 pi, but really we could just put 0 and it looks exactly the same because there's really not much I could do with it, you know? Next one's a little bit better. Rectangular coordinate plane value is 0 comma -1. How far is that from the pole? Still 1. But then what's the angle measure? Let's put it as a positive, even though we don't have rules here. What is that angle measure that's that rotated that way? 3 pi/2. So that's kind of like what's going on here. You know, you got to be able to go back and forth. Then I'll change colors again just to change, you know, what we're doing here. 1 comma pi/2 as a polar point would be 1 away from the pole up here. What is that as a coordinate in a rectangular coordinate plane? 0, 1. So we're just playing around with this and making it. Where are you going? What, fumble? Was that a fumble? Yeah. All right, no one helped you on that. All right, and then the next one. All right, here we go. Now we got to think about the unit circle and coordinates. So you know 1 comma pi/6. Here's pi/6, and here's 1 away from the origin. What was that coordinate right here on the unit circle? You know, when you were 30 degrees rotated off the or off the positive x-axis. And the answer is anyone? Anyone? root, anyone? Root 3 over 2 comma 1/2. That was that coordinate, and some of you use that in order to, evaluate correctly the unit circle values. I just told my my BCers that you can't get away with not knowing the unit circle. Even our last unit, this is the last unit before the AP exam, although for BC we're going to add some additional units. Yay! But anyway, the last unit is full of unit circle evaluations. It's all over. If you still can't evaluate the unit circle, you're doomed. Forget it. It's over. And then what does this mean? This is only half as far. So what that would be is wrong, 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 wrong. Half as far those coordinates would be. So I'd take half of those coordinates. All right. And that's what those coordinates would be. Now I'm going to draw this out because we don't have a formula yet for this. So I'm going to go ahead and draw this, and then I'm going to change colors just for purposes of looking fun. 3, -3, and then back to the origin. What kind of triangle is that? Red, right? But it's also what? 45, 45, 90. And then last hour just looked at me like I was an alien. But I am pretty sure, I wish I was, actually. But I could have swore that when we first did this, I derived the 45, 45, 90s and 30, 60, 90s with the Pythagorean theorem. Remember 1, 1, 1 root 2? Do you remember that? And then, but actually it was A root 2. It didn't matter what A was. This was going to hold true all the time. Why did I just cover that? What is this right here then? What is that length right there? A root 2, so it's 3 root 2. So R is 3 root 2, right? Distance to the pole. And then what's that angle measure? Don't say 45. Okay, what is that on the unit circle in quadrant 4? 7 pi over 4. I don't know how else they wanted me to do this. I just wanted to think about it. Just graph it and then common sense it. That's what I wanted to do. Because now the formulas are coming. But you know what I'm going to do for these formulas? And I think you should do the same. Because I think I have enough space for this. I'm just going to put one coordinate plane right here. And I'm going to, no, wrong. I like this one. I really want to emphasize the first quadrant. It doesn't have to be in the first quadrant, but this is what's gonna. It's always good to know where a formula comes from, so you don't have to memorize. You can use common sense. All right. And I think in green, I'll do the coordinate rectangular plane. So don't you agree that this is X and this is Y? Because this is X comma Y, right? Right X, up Y. So that's the rectangular coordinate plane. That's how we move in a rectangular coordinate plane. I just repeated myself. So, but I got to make some connections here and how these boxes are going to get filled out for the formula. What's this called? It starts with a T, and no one knew what to say on that. It's our most common letter we use. TH, theta. Someone said thesaurus last hour. I'm like, oh my goodness. Theta, that's a terrible looking theta. And then you know what? I'm going to use this color. What's this called? What's this line called? I'm going to stay red. What's this line called? What's this line? X, Y, come on. Sir, kicks or ticks. What's X, Y, and... Well, I'm going to throw a podium. Sir, kicks or ticks. X, Y, what's that letter up there? Oh my goodness. Violence in math. Arr. Yes, sir. Huh? What's the matter? Oh, you can't see that? Okay. I apologize. But I did say sir kicks or ticks. But let me see this. I could see. No, you're right. Oh. I could see it on this screen. All right. They can't see this little dot moving back and forth in class. So they say. No, they. Okay, so here we go. You ready? All right. So how do I find R? How do I find R if I know X and Y? And I'm going to leave this in green. How do I find R if I know X and Y? Pythagorean theorem. So X squared R squared equals X squared plus Y squared, right? How do I find theta if I know Y and X? Hey, what side is this? What side is this? What side is this? Oh, are you guys blind? No, they can't see this little dot. What side is this? You guys are killing me. What side is that? Opposite. What side is this? What's opposite over adjacent? That's why this is sitting here. Y over X. So tan of theta equals Y over X, right? Okay, now let's change the colors to red. All right. And now how do I get X? Well, what is X? All right. Okay. Well, say you were given this and given this now. And then I had to find X. What side is this? What side is that? Adjacent. And what side is this? Since you can't see anything. Hypotenuse. What's adjacent over hypotenuse? So cosine of theta equals X. Well, that's just Kixer, you fools. And then if you multiply both sides by R, then that's what X is, right? And then we're going to do it again. What side is this? Opposite. And then what side is this? Adjacent. So this is sine, maybe I'll put it out here. Sine theta is equal to Y over R. And then multiply both sides by R. Okay, so that's how you use these formulas to toggle between rectangular and polar. Got it? And polar to rectangular. And it's common sense. If you just drew it, you'd be able to do it from February's work. It really is. It really is. So, what are the rectangular? Notice that they don't say the Cartesian coordinates. Rectangular coordinates, which I said was going to happen. Well, first of all, common sense says that 3 comma negative pi over 2. I think I did this wrong the other hour. No, this is the one. So I go 3 from the origin. No, it isn't. It isn't. It isn't. I'm a liar and a bum. Isn't that 3 comma negative pi over 2, right? What is that as a coordinate? We should already know the answer. 0 comma negative 3. But here's the formula in action. X equals 3 cosine negative pi over 2. And then Y equals 3 sine negative pi over 2. So do you see how you could trick yourself into not memorizing understanding? Understanding from previous knowledge and how simple this could actually be. The cosine of negative pi over 2 is 0, because that's 0 comma negative 1 down there. And then sine of negative pi over 2 is negative 1. We still get that. This is the one. All right, you know what? I got to erase this. I got to erase this. Oh, I hope the video works. All right. So first of all, we got a problem with this. All right. Not really. We're just going to go ahead and plug it in. We're going to go ahead and just plug it in. Let's be robots on this one. So X equals negative 2 cosine 3 pi over 4. Y is negative 2 sine 3 pi over 4. But here's where I get to tell you about what happens with this negative radius, right? And then how it actually graphs. It's the other one I got to worry about. I was thinking about our next questions. Negative 2 comma, or not negative 2 comma, negative 2 times. Cosine in quadrant 2 is negative, and it's negative root 2 over 2. Sine of 3 pi over 4 is positive root 2 over 2. And then look at when I multiply these together. I get root 2 comma negative root 2 over 2. Which quadrant is root 2 comma negative root 2 over 2 in? What quadrant is that in? 4. So root 2 right, root 2 down. Now notice this. 3 pi over 4 is in quadrant 2, but it's a negative radius, which does what? 180 reflection. And this is proof of that by what I just did right here. There's the connection about a negative radii and how it flips 180. All right. Isn't this negative 4 comma 0 right here? Everyone should know what this answer is then. How far are you from the pole? How far are you from the pole? 4. And then what is that angle measure on the unit circle right there? Pi. Watch what happens with this, though. We got a problem. Watch the robots, which it's okay. Wrong. That's not okay. How do I find r? I find r by doing r squared equals, or you know what? You know what we should do up here? We should do this. Yoink, yoink, right? So what is r equal to? The square root of x squared plus y squared. So that's normally what we would see in a book. So this is negative 4 squared plus 0 squared. Yeah, that's 4. I got it. But here's the problem with theta. And really what theta is inverse tan. You know, so if tan theta equals, then it's inverse tan of 0 over negative 4. The problem here is you need to graph this coordinate either in your head or actually on your paper so you access the right angle measure. Because when you type this, if this was a calculator question on your calculator, here is the answer you're going to get. 0 radians, which is where? To the right. Is that where this coordinate is? No. Your calculator cannot give you 2 answers. From 0 to pi, there's almost always 2 answers that are correct in a unit circle. The calculator only can give you 1. So you're not using your calculator, I know that. But when that does happen, you really got to think and use your brain and make sure that you understand that that is in the right spot. It's going to happen on this next one. Darn tootin'. All right, so here's r. Square root of 6 squared and 6 squared. I'm just, negative 6 squared. Come on. If you're still squaring a negative and putting a negative down, you make me sad. You're a button pushing bum. By the way, 6, 6, 6. Ah! 6 what? You got to say the last thing so we're okay. Public school. 6, 6, 6 roots. Nobody? Nobody? Nothing? Crickets? Do I have to get the Cricket app out? Hold on, let's give it a second. It has been the stock market 1,600 down right now. I just looked at my phone, first thing that came up. This is really worth it. This is all I get in 5th hour. 6, 6, 6 root 2. This is a 45, 45, 90. Okay? But actually, that's what the square root of 72 is. What time is it? Do I have time for the Cricket? Probably not. I got to get moving here. Then here's my whole point for this. Inverse tan of, what's 6 over negative 6? Negative 1. What kind of angle measure is that? 45. But what quadrant? You fools? You got to graph it. Negative 6, comma 6. What quadrant are we in? 2. So your calculator will give you something. I don't think your calculator gives you. I think the calculator will give you negative 45 or the decimal negative pi over 4. That's in quadrant 4. But what we want to do, I guess you have options, but what really it is 3 pi over 4. All right, so that's what it's got to be. You put 7 pi over 4, you're gone, because that's not where negative 6 comma 6 lands. Negative 6 comma 6 lands in quadrant 2. Your angle measure must be in quadrant 2. Right? I know I'm screwing around here, but this is not screwing around. This requires thinking, not robotic, putting it in a formula and just whatever the thing tells me, I put it on my paper. There's too many people like that. It drives me nuts. Nuts! 2 root 3 comma negative 2. Hey, everyone. A root 3. Do the last one. 2a. This is an a root 3. Negative. 2a. Guess what r is? Guess what r is? 4. Guess what theta is? What angle is opposite the a side, a 30 or a 60? So you guys are untrained on this. It's a 30. See, I can look at this and I know I'm dealing with a 30. What's the 30 in quadrant 4? 11. What is that? I did an 11, then I put a hat on it. 11 pi over 6. Okay? That's 11 pi over 6 right there. So you must think about, or actually graph the point so you access the correct angle measure. All right? Or you could use your formula and be a robot and you'll be fine. Okay, now go to your graphing calculator, get it out. I think I got mine ready. Okay, and then I got to move my podium over here because I got this cord attached to me, recording my voice on my ShamWow things I have in my ears. Just like you. Anyone else got the big ear things? Illegal. Anyway. You know what I'm gonna do first before I actually do this, and I feel like they're a little bit going ahead of the game here, but I'm gonna go ahead and multiply both sides by r and r. Why? Because then I'm gonna go ahead and do some replacements, and then this is how you toggle between polar and rectangular. Hey guys, what's r squared equal to? You shouldn't have to look at the previous page. What's r squared equal to? X squared plus y squared. What time is it right now? Oh, sorry. Oh, we got an infinite amount. Like, it feels like it, doesn't it? Like, you look at the clock. Are we still in here? Oh my gosh. All right, we got a lot of time. What's r sine theta, everyone? Crickets. Here we go. R sine theta is what? Y. There we go. Oh, back in the 90s. What's our sign theta? Why, Mr. Samuelus? We love you. Oh, thanks, guys. Just, keep it to yourselves, But thanks. Now it's nothing. They're just sitting there thinking about their phones. What's on my phone? What am I missing? I'm missing something on my phone. Something's going on Chapsnat. All right. Did you just see what I just did there? You know what we're gonna do next? We're gonna complete. Who did I have last year? You're in trouble. You're in trouble. You're always in trouble. Anyway, that's it. You're the only two that I had last year. Am I missing something? You're in trouble. We're gonna complete the square. When I say complete the square, you say take half. Okay, what else? Take half the middle term, and then what? Square it. What's half of -4? What's -2 squared? Whatever you do to one side, say it. You did this last year. This was during conic sections. Okay, I can't remember us completing the square once this year. I may be wrong. I don't remember where that would have come about. And then what you got to do is this. And by the way, you know what's great? This factors. Sometimes on the what's that test next week you're taking? You're so sick of hearing about it, aren't you? How many people got pulled into that ACT thing during their study halls? Wasn't it during study halls? Okay, or Compass, during Compass. Okay, anyway. And then, you know what this is? This is a circle with a center at 0, 2 and a radius of square root of 4, which is 2. All right, and that's what you got to remember. Now we're going to go to the graphing calculator. Here's what you got to do first. All right, I thought I hit it. There we go. Let me expand this. Hurt myself. Doink. Don't worry about this, but go ahead and hit mode real quick. Hey, you people in physics, now you have something else to worry about. Radians, degrees, and now you're going to have to toggle between this mode and this mode. Right there. We now want to go into polar. All right? Oh, no. You know how to do this on that one?
I'll look it up later.
Yeah, okay. All right, we have someone with an Inspire in here. Okay, so y equals, there we go, clear. Now go to y equals, isn't that wild? Got r equals now. What we're gonna do is prove that that previous one I just did ends up being a circle with a radius of 2. So what was the original? It was just r equals 4 sine theta. So that's what we're gonna put in there. And then you're gonna have to mess with your window. I already did. Ah, darn it, this is not working so well with the cord on my, then I keep toggling. Here, I'll do this. I'll move it over. But you go ahead and beat me there, and then you might want to toggle your window. I'll show you what I did here. Ooh, man, that's not looking good. It's like I gotta move this. This is, I don't know why I left this here. Okay. All right. Ah, lost it again. Watch the guy on the internet fumble around with this technology. Okay, what was it? 4 sine theta? Okay, then if you're jumping ahead of me, good. If you don't like your window, then do this. This is what I did. I wanted the window to be, you got to leave this. Hey, what's 6.28? The same thing as 2 pi. So it's graphing this just from 0 to 2 pi. I'll show you what that means, like if you did more. All it would do is keep overwriting on itself, so it wouldn't change the graph. Other graphs, not so much. It's interesting. You're in a different world now with polar. X min max, -5, 5. Just imagine a rectangular coordinate plane. I just want to go 5 to -5, and then same thing for y. Why did I do that? Because the radius was only 2, but it's centered at 0, 2, right? 0, 2, correct? So that means it goes as high as 4. 0, 2, 2 up, 2 down. And then when I hit graph now, I could see that that's a circle. Why does it not look like a circle? There's some distortion. It looks like an ellipse, but the x-axis is projected wider than the y-axis on my thing over here. And there you go. There's a rectangular to polar. We typed in a polar, but we still see this rectangular circle. We see a circle like we're supposed to. All right. And then I don't know. I think I did that, and that's what was all about. There's the directions for this, and then I didn't zoom square. I actually manipulated the window by hand. All right. So yeah, that worked out really well. Okay, so what can we expect for this picture? First of all, this is not ready to be graphed. I would have to divide both sides by sine, but wait, what is our sine theta? What is our sine theta? Y. What kind of line is y equals 3? Straight, red. It's horizontal. So how would I type this on, in our calculator? I'd have to divide by sine theta. All right, and then you go ahead if you want to play and type it in your calculator. Yes? I can't, because I have to touch my calculator over here. I wish this was I can't believe this isn't cordless. And every time I hit this, it doesn't work. All right? All right, fine, I'll do it. What was it? 2? 2 divided by? I already forgot. 3? 3 divided by, was it sine theta? Sine theta. You know what else I should have checked? My bad, dogs. Make sure you're also in radians. I don't know what would happen in degrees. I think it'd be pretty messed up. Boom. Isn't that weird? Y equals 3. Next one. Hey, what's secant? 1 over cosine. -1 over cosine. And then you know what? To get this in rectangular, multiply both sides by cosine. Get rid of that little tick mark there. And then what's our cosine theta? What kind of line is x equals -1? Straight, red, vertical. You can go ahead and type that one. You don't have he has a secant button. You'd have to type this in and then press enter and you'll get a vertical line. You cannot graph a vertical line on a graphing calculator. Well, there is a way. It's through menu. I haven't done it in years, but anyway. Oh, how do I do this one? I know. What's r equal to? I actually have it on the other page. What's r equal to? The square root of x squared plus y squared. And then you square both sides. Don't worry about extraneous solutions. We're not solving. 1 squared is still 1. That's a circle centered at the origin with a radius of 1. So now when you just go to your graphing calculator, I guess I could just do it here without going to the board, but I hate it. I hate it. I hate it. Y equals, I'm going to clear out, clear, and then just r equals 1, and then press graph. So guess what r equals 2 is? Guess what r equals 2 is? Circle with a radius of what? 2, and so on and so on and so forth. Okay, we could do this all day long. All right. It's nice. It's cool. It's interesting. Whoa. What? Okay. You can go ahead and play on your calculator real quick. Whatever you do to one side, though, say it. I'm going to go ahead and do the, what's he doing? Do the operations in order to get this to be rectangular. Hey, what's our cosine theta? X. What's our sine theta? What's y equals negative x plus 2? What's that a picture of? What's that a picture of? A line with a slope of -1 and a y-intercept of 2. Is that what you got when you type that in your r equals? Have to get the crickets out. Anyone? 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 Bueller? Yeah. Anyone know that movie? Okay, I don't feel like typing it on the calculator. This was wild. Illegal! This teacher should be fired. What's missing? Theta. Okay, and then this is r minus r cosine theta. This is going to be wild. Oh, guess what? You're going to get some more conic sections. What's r? No time. What's r cosine theta? And then I'm going to add x and square because of time. Add x and square. Fine, I added x, and then I squared both sides. I'll take a little bit of a minute. And then good factor, say it. FOIL. I swear to dog, my ABers, some of them still can't FOIL. I want to cry. I cry myself to sleep every night thinking about AB students that can't factor because they can't FOIL. Cry. What happens to the x squareds, everybody? They cancel. And then are you ready for this? Boom, 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 boom. Do you remember that you take a 4 out and then we did this for parabolas? A y squared is a right lefter. The vertex is at 1, negative, comma 0. So the vertex is at -1, 0. Do you remember 4 came from, this is where we get our p value. P is the key. Remember you two? And you? Where's your ID? So what is P? What number is it? Anyone know? It's not 4. It's 1. You do remember. Because this is the 4P number. It's a formula that you had to remember. So what did we do? We went to -1, 0, and then we P'd right. What? And then we P'd left. What? And then cereal bowl, say it. Cereal bowl table. Cereal bowl table. You guys didn't have me, so you didn't do cereal bowl table technology because the bowl sits on the table. The directrix is the table because this is a parabola that goes right. And then 4 is the focal width. So this is 2 up and 2 down. And then this point is there and that point's there. And then that's that picture. It's y squared, so it goes right because this is positive. P is the key, 1 right, 1 left from the vertex to get the focus and directrix. You guys remember this? You're the only people in this school. Oh, you always do that. No, I don't remember that. Always, 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 always. Hey, what's x squared plus y squared? R squared. What's 16? 16. All right, and then when you square root that, that's r equals, I know it's plus minus 4, but negative radii, positive radii, they all create the same thing. What's this going to be a picture of? A circle with radius what? It's 4. So we already know that. But next one, hey, what's x equal to? R cosine theta. And then this is equal to r equals -1 over cosine theta. You want to get nuts? I just did truths. And the truth is that y is r sine theta. What time is it? Oh. And then what's x equal to? And then I just did this. I'm like, you know what? I don't know what to do on this. So here's what I did next. And then two people fainted in fourth hour. It's like, what? R squared is R squared is R, and sine squared is sine, sine. Sine, everywhere, sine. Do this, don't do that. Can't you read the sign? I can't help it. I love that song. And then how do I get the R by itself? Then I'd multiply both sides by cosine over sine squared. Cosine over sine squared. And then you're going to be amazed when you graph this. If you graph this, you will get a parabola that is going right, vertex at the origin. And that's what this picture is going to do. And actually, I will do that to end off these notes. Is that the end of the notes, right? Except for a little statement at the end that I refuse to fill out. All right, y equals. Let's cheat as they put their stuff away, and let's do the little fraction button because we can't do fractions anymore. We're gonna have a button for it. 2 cosine theta divided by, you know how you have to do sine squared, you gotta do it what it actually means, which is sine theta, close, and then square it. Be ready to be amazed. Is anyone even watching? Hi-oh! What is that a picture of? Parabola, what's its vertex? 1 or 0, 0? What? What? All right, that was me. And then a focal width of 2, right? So this should be at 1 comma 1 and 1 comma negative 1. It looks a little bit bigger than that. I don't know, but that's really what should happen, right? Wasn't it y squared equals 2x? Yeah, that's a little different, but good enough. All right, good, perfect, nice. Hey, am I going to be here tomorrow? Yes or no? No, I'm not. But hey, no one is. Am I going to be here Monday? No. All right.
Bye, Mr. Samuel.
Bye, Sammy Samuelus. Going to.